Welcome. I am here with Dr. Holly Gaff. She is a professor and chair of biological sciences at Old Dominion University. Thank you, Holly, for joining me.
Welcome. Thanks for having me today.
Thank you. First, I just want to start with this. I've talked to a lot of tick experts and I've learned a lot about ticks, and I think you're the first one that has a PhD in math. So, can you tell us the story how you got from a PhD in math to now being a tick expert and a tick studier?
Sure. So yeah, I mean, life is always a journey, right? And you always go interesting directions. I started out in math in undergraduate, but always had interest in other things, particularly in biology, and looked at math pre med and thought about going to medical school, and got convinced that it would be more interesting to go off to graduate school. So then I was debating, math, bio, all the things. Ended up going for my PhD in math. But my PhD advisor knew I still had this real interest in medical bent, and so he happened to be on a committee of a entomology master's student who was studying an outbreak of ehrlichiosis in Cumberland County, Tennessee, in the mid-90s. And he came back with this data set from one of the meetings with the student and said, "Here's a really interesting situation that no one's really built mathematical models for this particular kind of system. We didn't have a lot of PCR back then, and so they were doing some tick control, and the big question was, what is the impact going to be on the tick-borne disease given what they're doing for the tick populations?" And I said, "Oh, that sounds kind of cool." No, and at the time, there weren't a whole lot of folks doing mathematical modeling for ticks, and so I started down that road and did that for half my dissertation, and then continued into like disease modeling was kind of a more broader term, and took a very scenic route in life and did some consulting and some defense consulting, and we had 9/11, we had a whole bunch of other world changed, and ended up finally at the University of Maryland School of Medicine and started looking back to try and get back to doing some of the tick work around 2005, after 5 or 6 years of wandering in the wilderness, as I call it, and ended up then coming down here to Old Dominion University, and Dr. Dan Sonnenschein was here for 54 years studying ticks, and if you've ever read the Biology of Ticks, Volume 1, Volume 2, the old ones, the new ones, he's kind of an international tick god. And so one of the things I always struggled with for building mathematical models of tick-borne diseases was the lack of good data to support modeling.
Okay.
And by what I mean by that is that?
Can you just quickly what exactly is mathematical modeling?
So mathematical modeling, really, we're looking at trying to use what we know about the dynamics of the system to understand it, right? Eventually, someday, maybe predict it, but more it's about the understanding of it. So, for example, this Tennessee outbreak that started my question, it was when you go mucking about with populations in a complex system like tick-borne diseases, it's not always to your advantage. You may actually somehow amplify the pathogen. And so that was kind of my original question was, is this tick control going to make the risk of tick encounter might be lower, but the risk of disease given tick encounter might be higher? And so it's something you struggle with to do in the field, but we can do on the math side. So that's what spoiler alert, it actually makes it better. So that was a good outcome. So the control was probably actually doing good things for that particular pathogen in that particular system. So for many years, tried to continue to develop models. I was more working on the rickettsia side. I wasn't doing as much on the Lyme disease side, more of the ehrlichiosis and Rocky Mountain spotted fever, kind of exploring those areas. Again, got here to Old Dominion University, and I didn't ever like any of the data sets, even the original data set that I had, because we don't have a good network for surveillance for ticks in our country. And so we end up with data sets that are collected when there is an outbreak. And so it's unclear to know what differences there would be if in any given time, right? So Dan Sonnenschein was the one who really convinced me of this, because I figured, okay, like, this guy's been doing ticks for 50 years. He's going to have data for me to build better models. And I went to him, and he is one of the best mentors you could ever have in the world. And he looked at me and he's like, well, this part was true. No one's ever really collected data thinking about modeling. And so he challenged me to go out and start collecting data to think about modeling. And then he did kind of trick me a little bit and said, it'll be really easy. Just go out for a few years, collect a few ticks, and you can come back and do your math in your nice air-conditioned office. So in 2009, I started out on tick surveillance here in the Hampton Roads area of Virginia. And yeah, 350,000 ticks later, I think I know less than when I started.
350,000 ticks?
Yeah, at this point, collected, processed, most of them have been tested. We know a lot about, like, we've watched tick populations move in from the south. We have the aggressive black-legged tick variant coming down from the north. And so Virginia is a really dynamic place. In the 15 years we've been out, things have changed dramatically under our feet as we're collecting it. So we continue to collect these data to try to better understand it. We're trying to finally getting back to doing some modeling now with some of the data that we have to give a better understanding of what we can do, what we can understand about what's driving these populations over space and time.
So you're saying, obviously, so you're seeing a lot more ticks come into your area. And as you look at the maps of the disease too, like everything's just kind of growing out. And it always, Lyme, obviously kind of New England, mid-Atlantic, and then south, more like the Lone Star. So, but Virginia's, dead in the middle there. So everything kind of going up and coming down.
Yeah, we're filling in that middle section there. I mean, it's definitely Lyme disease has moved through since started about 2007 into Virginia. Well, parts of Virginia, the central and western parts of Virginia. Yeah, and then we have the Gulf Coast tick moving up from the south, and a couple other non-human biters that have shifted in our area that are shifting pathogens in the wildlife that will eventually spill over into humans as well.
So I guess the goal then with the modeling that is different from, we meet with people like other people in the tick-borne disease, and then they're getting ticks. They're seeing what's in the neighborhood. They're going out all the time with their white flags. What's different then with what you're doing? Because they're seeing, here's what we've got, but are they not kind of taking to the next level to like then say, this is about prediction of like future of ticks?
So we do a little bit with the prediction aspect, but I think we don't even know enough about ticks to know to predict, right? So again, models can be used for one of two things. You can use them for prediction, which we do a little bit of understanding to try and understand. I always get asked, is it going to be a bad tick year? But I mean, these suckers live for a couple of years. And at least here, we may or may not have a hurricane. I know there's one off the shore right now, right? We may or may not have winter with snow. We may or may not have, we have all the different changes in the host populations over those 2 or 3 years to be, so it's a highly complex system. So the goals with our models is really, hey, if I put in everything I do know, which piece should I spend next year's field season studying? So it's a lot about, it looks like this aspect, for example, off-host survival, right? We all know off-host survival probably matters a lot and how it accumulates over time. So we're going to spend a little time on that. We also want to know what is the energy cost of questing, right? So ticks, when they're active, aren't always up questing for a host. They may be just ready to, and so it's starting to work on understanding how much does it cost them in fat reserves to move towards a host. So we're looking at ways of measuring tick fat and understanding, like, okay, then if you put them in different conditions, how quickly do they burn through their reserves if you have, exposure to host cues or not exposure to host cues. And so really that level of information it seems like the model says is pretty critical to understanding how long they live, which explains their dynamics, which explains the risk to humans. So it's
so at the end, though,
a lot of pieces.
So and then the final goal is, but because the diseases and the germs ticks are carrying that make people sick. So that's like kind of why ticks are interesting in that way, because we want to not have I've asked people, other scientists, if like we need ticks. Because I like mosquitoes, I know are food for a lot, and I've had some differing answers. I don't know what your answer. I mean, they're in the system, so it's hard to think there's a reason or not, or maybe there was a reason, there's not now. You have a theory on that?
So I get asked that a lot, right? I mean, those ticks are awful. Just get rid of all of them. I'm like, it's never a good idea to mess with Mother Nature, but I also think about how many times ticks can provide a blood meal to another animal, right? So the classic mental image is the oxpecker on the back of a buffalo, and in Africa, that bird could not eat a buffalo by itself, but it can eat it one bite at a time as it comes off in these ectoparasites. And so it's not just ticks they eat, but they eat all kinds of other parasites. And so parasites can be one way to jokingly eat the elephant one bite at a time. But they also, so they do provide a food source for some things. They exsanguinate the weak, which sounds like, I mean, it's an awful thing. People don't like that answer much.
Yeah.
If there's a weak animal, they will make it sick enough to die.
Gotcha.
So evolutionarily, it's stronger for the host species to lose the weak ones, but that anthropomorphically we don't like that very much. We don't want the sad little ill young fawn to die, but that's better for the deer population in general. So
that's a whole nother another conversation. Yeah. Okay, so at the end, I mean, this study of ticks now is, I think, becoming more and more folks are out there really looking at them, because more and more, especially in the U.S., in the U.S. that's our insect, our vector that is causing, or not actually, because not insects, that's causing the sickness. Where obviously mosquitoes are and mosquitoes coming here some with disease, but ticks are our number one, and that issue is growing and growing. So one thing, I know it's been a few years since you did this, but I'd love for you to talk about TickBot. So things that you're looking at in the field that potentially can help people reduce the tick populations in your area. So tell us how you got to that and exactly what TickBot is. So maybe I can get a picture of TickBot up on the screen at this point in the video, because he's a funny little guy.
It is a funny little guy, yeah. It was again, it goes back to Dan Sonnenschein, so it was his invention to start with. Working with some engineers over at Virginia Military Institute, they developed the idea of trying to minimize the risk of human interventions in a yard. And so it's this little semi-automatic vehicle that can drag a cloth that's treated with permethrin, and permethrin or permethrin-impregnated materials will kill ticks on contact. And so the idea kind of flips the idea around. So goal is not to actually eradicate tick populations. The goal is to create a safe zone for you to be in. So I talk about it a lot as, it's like a vacuum, like a Roomba, right? A vacuum cleaner. We don't expect there not to be dirt in the world, but we do expect our houses to be clean. And so I think it's the same kind of approach for ticks, where I don't expect the world not to have ticks, but I can try to make my backyard clean. And so we experimentally tried it in a couple different field sites around here over the years. And you can eradicate ticks for 24 to 48 hours, or 95, 99% of them will be reduced, or eliminated, killed by this material. And so it drives around, has a little CO2 emitter of some kind. Experimenting with all kinds of different ways of doing CO2 with a little bit of dry ice, or with some kind of CO2 tank. We're still working at all the final details that hopefully eventually can get it out there on the market, so that someone could buy it and run it in their backyard before they have people over, before they go out to play. It could be something that could be used more residentially, or we have a lot of the field sites here that if they know they're having, one of the sites had a Boy Scout camp coming for a camp over for a weekend, so we went on Friday before and at least ran it to try to reduce the tick population in that specific area for that very specific time. And again, the goal, it's never gonna reduce your tick population, because it's a small percent that you're hitting. But I think of it more as keeping your yard clean as possible from ticks that are entering your area.
Well, I guess on that note too, I think a lot of people don't realize that their yard is a tick habitat, because so much is talked about, stay in the middle of the trail. It's so much more to hikers and folks like that. So, I mean, obviously then you guys, you're studying yards, and you can show to people they're in your yard.
Absolutely. If you have a woods, if you've ever seen a deer in your yard, you have ticks in your yard. I mean, that is definitely especially for the Lone Star tick that we have down here in the Southeast, which is just ubiquitous and aggressive, and much less passive than the black-legged tick up north. Even the black-legged northern variant of the black-legged tick is not as in my opinion, it's not as aggressive as the Lone Star.
Yeah, I've seen Lone Star. We had one where we were filming different ticks and we were just kind of putting them down on a white cloth. And the Lone Stars were just, they were all moving. They were fast. They're fast. And I don't think people realize like that, like they're like a race car versus like it's like someone in a car versus a bike. You know, like that baby is on the go and they can move darn fast.
Absolutely, they're little bullies that'll come take your lunch money if you're not careful. That's how I describe them to people.
The one other thing too with the studies you've done, I've had people ask me, said, "Oh, I hear if I have like chickens in my yard, that can help reduce ticks." Yeah. And then I know you did some work with like guinea fowl. What is the story on that? And does that help having chickens in the yard to reduce ticks?
So it's a complicated situation, right? This is one of those predator-prey switching is the term we kind of think about it. So one of my PhD students, Alexis White, Dr. White, is now up in University of Rhode Island as a postdoc up there, working with folks up there. But she went over and led this study where they actually did enclosures and exclosures. So they put guinea fowl in with known number of ticks and kept them out of other places without ticks and looked at the ratio, as well as did this, I would call it, horrific in my opinion, but what grad students are good for, of putting a tarp underneath the guinea fowl coop and searching through the poop every night. So the enclosures with guinea fowl did have fewer ticks, but what the theory of what we found in this preliminary work was that actually they were then falling onto the tarp fed. So it's not so much that they eat the ticks, they probably absorb the ticks, so they may be taking some of those ticks for you, but then the question is, over about a 4 or 5 year period, you've now got more fed ticks in your yard, which will make more ticks, right? So I think that they may do some perceived reduction in those first couple years because, yeah, they're absorbing ticks that would otherwise be coming after you. But after that, we didn't, then she had the nerve to graduate before we got 3 or 4 years of data, right? But I think over the longer term, you may end up either back where you were or worse because these ticks, one female Lone Star can lay 5,000 eggs. Right, and you feed that Lone Star on one chicken or one guinea fowl, and it's just it's unclear who wins that in the long run.
Yeah, because I guess in one sense you're introducing your own host to your yard potentially. It's like if I was like, let me have like little white-legged, I'm going to have a little mouse population in my backyard because I love little mice, and actually I'm just bringing in a host. So yeah, I can see that.
Right, and so in the initial, they'll absorb that, right? So it's an ecological mop or ecological sponge. You can think of it, they're absorbing those ticks. So that first few years, you do feel that perception of a lot lower. But long term, I don't know that it's the right idea based on what she was finding.
Right, because you don't want to be feeding the ticks, and then you're feeding the ticks. You're giving them the blood meal. And then there's that 5,000 more out of one. And then, the numbers exponentially, all of a sudden you've got massive tick infestation potentially.
Yep.
So that makes sense now. So people maybe in the beginning were like, oh, hey, I have less ticks because it was just that first year or two. And they're not looking long term, which is science working for the future and modeling out.
Exactly. That's where she built a little model and she's like, yeah, you're not going to win in the long run based on even if it's a small number that feeds successfully, they'll
Okay, I want to go back
amplify.
to the one thing you were talking about with the ticks and the like kind of the fat reserves and how much like time and they're going to go out and do their energy usage, because we have a lot of people and it's that insist to us that ticks crawl up trees and then they fall down from trees. And I mean, thinking of it, I think we've always, I've had Dr. Mather, I've had others, a lot of other, no. And then people come back to us and they insist. I mean, it's probably the most adamant, like people are like, you are so wrong. You people don't know what you're talking about. But I think it's a good way to think of it differently because they don't believe it. But if you think how much energy, calories, like, I'm going to go, that'd be me like running a marathon plus. What is that? If it tick to go up a tree, what's your response when people say to you, of course they're in trees. They fall on my head all the time.
Yeah, I get that one. I fight that one all the time. And it's a combination, exactly as you said, energy dynamics, right? There's no advantage to dropping down, but they're also So they would use a lot of their energy and the desiccation factor, right? There's such low humidity in the tree that they would desiccate, dry out very quickly and die. And people don't like, so I had an individual who really argued with me on this. And so I gave him a challenge. I gave him a can of permethrin and I said, okay, treat your shoes for 3 weeks. I said, here's the can, spray your shoes. And if they do fall from trees, then you will have the same number of ticks when you come back in 3 weeks. I saw them every 3 weeks for a meeting. If they fall from trees, you have the same number. If they crawl up you, like I say, then you will have far fewer because they will have crossed over that insecticide barrier and die. And he came back, sure enough, 3 weeks later, and he went from having thousands of ticks a week to having 2. So I think sometimes we just have to challenge them to try and see. And so they don't believe they wouldn't feel it crawling up them. They don't believe they wouldn't have this perception. That obviously if you find it on your head that it came down, or they'll see pollen falling or something else falling, but it's just biologically it can't happen. And now I will put the caveat. I had a grad student go with me to Africa when I was working over there, that ticks that feed on giraffes do actually climb trees. So there are ticks in the world that they don't fall on us, right? They're attacking a giraffe, and so unless you have animals that tall,
right,
there's no advantage to it. But it was entertaining because my students were like, there are ticks in the trees. You said there are never ticks in trees. And so I now put the caveat on this that unless you have giraffes,
gotcha,
then the particular ticks that are after very, very tall animals will go up. But the deer, if their target is deer, there's no point in climbing up.
Right.
So,
well, thank you. It's always good to just have another response to that, because it is one. And I think to 2 points is one, people, they freak out thinking I climbed all the way up to my head, or there are many other things that fall from trees that look like ticks. So then we always say, well, there are many, I've seen probably a lot more ticks than a lot of people, and I've looked at tick pictures. I've seen ticks. I talked to a lot of people about ticks. They're hard to there's also a lot of, I look at pictures of other arachnids that look similar. I couldn't necessarily tell a difference. So I think there's so many lookalikes that I think also get people on that thought.
Absolutely. Yeah. We've been sent out many places to collect. There are so many ticks in these areas, and you get there and you're like, sorry, these are beetles or ticks or spiders or anything else. Not the ticks we're looking for.
We've challenged people. Okay, next time to get one and then take a picture of it and send it in. Or of course, that doesn't happen. But no, it's very interesting. And the world of ticks, and it is that, and they're all over. So I didn't know they had a lot in Africa. So a lot of ticks in Africa.
Yeah, the African work is almost all animal tick basis. So like you said, it's the number one vector for human diseases here in the U.S. There are very few human tick-borne diseases in Africa, sub-Saharan Africa particularly, but they can be a very big problem for their livestock at the wildlife-livestock interface, and this can really be detrimental economically. So it's an economic issue in sub-Saharan Africa where we worked. So it's a very different approach in a ball game, but it's I think equally important whether it's human health here or human sustenance, right? That is their entire bank account basically can be lost to a tick-borne disease.
Ticks. So I guess one thing, as we said, we potentially, we need ticks. They're in the ecosystem now. We don't want to mess with all that. But protecting yourself, obviously, we use permethrin. Is that your main goal? What other thing? What do you recommend to people for themselves, for their, obviously, the yard kind of? What are your top, couple that you say to people? Here's what to do to protect yourself.
The first goal obviously is to not be in places where ticks are, but we also need green. So we have to have that balance of, the middle of the trail is a great idea. The being aware when you go out, the time of year is always important. But again, we do preach the use of permethrin or permethrin treated clothing. So I think every slide I've ever done and every outreach has an insect shield little link for it. It's the way to go in a lot of ways, particularly for Lone Star ticks, which are much more susceptible supermethrin. I jokingly tell people all the time they laugh at DEET. I mean, yes, DEET has some deterrence, but the Lone Star is gonna DEET's a little more effective for black-legged ticks than it is for Lone Star ticks. So, people can use what they need to use. We treat everything for the students in the lab that go out for all these tick collections we do. I provide them with permethrin to treat their boots, because again, that's the key thing in a lot of ways. And then, tick check when you come back inside. One of the other things I do that I don't know if there's I've never seen this commercially done, but I treat my car mats, I treat the car seats, I treat the inside of my car, so that when I do come back inside, kind of like you could treat your gear if you go camping. We're in and out of the car all the time in these tick areas, and certainly nothing as terrifying as driving your car with a tick walking across your windshield while you're on the freeway, to try not to die. But yeah, so that's when I started treating inside of my vehicles. But obviously then if you get home, take a shower, check all the spots, use tweezers or some other tick removal device. If you do find them, get them out immediately. We do encourage people to keep them and identify them. I know that there's a lot of discussion as to whether testing them is worthwhile or not. Depends on your medical provider, but certainly there are groups like mine that do some tick testing if they want that. And then just awareness. If you have like any, don't feel well in the few days after you've encountered a tick, or your dog has had a tick, because people amazingly don't always know that they had a tick bite, then to seek medical professional help. So there's my soapbox that I will get on at any chance I get and tell people.
Yes.
So
that matches. It's good every time to kind of hear it again and again and again to remind people.
Yep.
So I guess in closing, I did already have you debunk my favorite tick myth about ticks up in trees. Do you have a tick myth you like to debunk for folks, or you can share with us?
I think the tick removal myths are also ones that are really important to make sure that people don't try to use a match to make them back out. Don't try to use soap or anything else. I mean, ticks, female and immature ticks will excrete a cement to cement themselves to your skin to try to remain there for a couple weeks. And they are not going to be irritated to get back out of that. They're there against animals that have sharp teeth that try to bite them off. So there's not much you're going to do to encourage them to back out. So you really do need, again, a tick removal device. I mean, the tweezers, anything like that you can get down in there and pull directly up. You don't have to excise your skin, but pulling directly up and removing as much. And don't panic if you leave a little bit of that mouth part in there. It's like a splinter. It will grow itself out. But I see people all the time arguing that they will wait till they have this or wait to that, or try to get the tick to back out. And they've seen it on YouTube or TikTok or anywhere else where they watch these videos of, if you just do this, use a little oil and you can get the tick out. And it's not how ticks ticks work.
They don't reverse. They don't yeah.
No, they're once they're that far in, they're committed, and they're not going to be scared off.
Okay. Interesting. Well, thank you so much for sharing your tick knowledge, and it's fascinating your journey from math. And now, I mean, at the end of the day, math, you should tell math comes back to everything. Everything ends up having math in the world, from business to science to studying, humans and insects and arachnids. It's like there's these math kind of always kind of seems to come back in. That's why kids should always
absolutely
go study math.
Math is the universal everything. It'll get you a long ways. Yep.
All right. Well, thank you so much. I really appreciate your time.
Thank you.